This is the next session of our ongoing tutorial where we will understand how to use together Unity and ROS. If you remember well from the last part, we were able to publish the position and the orientation of all the joints of our robots back from Unity to ROS, but we were not able to communicate back from ROS to Unity. So in this session we'll do exactly this, and the objective is to be able to plan a trajectory, tell the robot that he has to take this target, which is a cube, and move it from this position to this one. In order to do this, let's first check that we have everything running correctly. First thing to check if his Docker here is running, otherwise you might have problems. Then you have to run the Docker you have to do docker run in order to obtain this prompt, which is something that we already seen. Once you are here, you can run ROS launch Nirio move it part 3. You should wait a moment because it might take something before it initializes all the nodes. And in the end, there will be a moment where it says, okay, you can plan like this now. You can start planning. This is the moment where everything is working. This error is not important. You can forget about it. It doesn't mind. If you would see any error before saying that some of the components couldn't execute, then you had to probably download again the container, because was a small mistake in the first one where you had to, when one of the file was not executable. You can either put it executable on the console, as I did in the last way that we showed the video, or you can download a new container from the web and it should work out of the box. Okay, now once we are sure that the ROS part is working correctly, then we will go back to the Unity part. Here, as you can see, I opened the scene for Siege plan, so please use the same because we made some modifications. The first things we should check is that in robotics ROS settings, you should have here, let's check again that this value are the correct one. This is your local IP. This should be the IP of the machine you are connected to, and you should put 20 as a timeout, because sometimes the machine is too slow to do it in 10 seconds, and if you don't, you might have strange errors if you don't put it a little more towards 20. In my case, planification usually took 12 seconds, so 20 is a good part. Okay, so what about the scene? So you see everything is connected. We have now the robot, which is here. We have a target cube. We have a place where we want to put the cube back. And then we have our publisher. You will see as a difference between the last part that in this time I removed the source destination component and I added the trajectory planner component. Those are scripts that you can find in asset scripts. So once you are in your publisher, if you don't see like I am, you can just take this, move it towards the component. You will see that now it is uploaded, and then you can connect all the slots. First the robot, then the target, and finally our placement place. We will look into together what all of this means. Once we are here in this part, we can already start the simulations, and you should see this vision of the robot, and here a button. Here sometimes my screen is too small so that it's difficult to show everything together, but you should be able to see this button. Before, the idea is that once you press this button, you would send the coordinates of the robot, of the targets, of the placement to ROS. ROS will make the trajectory and return it back to you, and you will see the robot moving. Before pressing the button, let's check if it is we are calling the correct function, just because it was different from the last one. So remember, this would be in canvas button. You can see here that in the on click there is none. So if we want to put something, we need to take the publisher object and drag it here. This would mean that once we press the button, we will call a method of the publisher object. The method we want to call is trajectory planning publish joins. So once this is done, we can open again our scene. And press the button. You would see that here there is an active service request. You can see the status of this in this place, and then you can move towards the ROS part to see that the planning is actually working. At the end of the planning, this should return a response, and you should see here the robot moving, picking up the cube and placing slowly in our desired target. Exactly. This will conclude this part of the tutorial. Then in the next one, we'll get more into detail in how all these parts work together. So stay tuned for the next update.